Hi everybody, my name is Raul. Today I'm going to present you the project that I have been involved through the last 4 months here in Concepcion, Chile. The project is about a monitoring system of the electrical variables of the Universidad of Concepcion. Uh, the idea becomes thanks to the Dr. Luis Garcia Santander, who is in charge of this project. As information in particular, the University of Concepcion is a public university, so that means the government allocates funds to pay the electrical bills of the university, and in particular, the management of those funds are managed by the university. Uh, with the help of this system, this monetary system, we can save money, and that saved money can be destined to another educational programs. So I'm going to give you a brief description of the project. At the university, we have 8 principal meters that correspond to the 8 principal bills to pay. Um, the fee that is contract to these buildings are the 84.3 that are for consumers in high voltage. Uh, we have 22 substations that supplies energy for all the buildings. These 22 substations have involved more than 80 smart meters. So the most important electrical variables to monitor are the power supply, the variation of the currents, and the cost of the energy. That we want to know how much we're gonna pay at the end of the month. Um, the objectives are clear. First, we want to implement a system of measurement, supervision, registration, and management of the electric power, manage it with the energy supervision platform that the maintenance department bring to us. The second is to determine system efficiency indices and saving opportunities. Um, the goals are once the energy system is implemented, a database will be able to allow the analysis of the behavior of the electrical variables. With this information, proposal can be developed to make more efficient consumption of the energy in the campus, to make projection of the values of these variables. So the system will be also allow sharing the information through the data network of the university, uh, so any user can have access to them. Um, it's very important to the regulations. So to develop this project, we must. Uh, it is need to stand by the standard ISO 5001 that is based on the management system model of continual improvement. This make it easier for organizations to integrate energy management into their overall efforts to improve quality and environmental management. Below this video, I add the link of this standard to if you want see more specific the points. So that we have. The maintenance department gave us the power to manage this platform that the, that they hired by Finnish contact company, and as we can see, we have the 22 points that represents the 22 substations of the university. Here we have the table of the 8 principal meters that correspond to the 8 bills that pay the university. If we click in one point, we can see the meters involved for that substations. In this case, we have the mechanical technology and we have 3 general meters. The education one includes our ads. It's in connecting serial with the general tree. These are the variables that we can see on that meters. We can see the voltage in the three lines, the currents in the three lines, the apparent, reactive, and active power, the power factor, and below we have the total amount of energy consumed. As a first impression, we can see that in the platform these variables are instantaneous, so they have like a storage. We don't have a database that storage this information. This is the principal problem, and the second one that we can visualize at the same time the variables of those meters that are involved in that substitution. That's why we propose to make our own database. This is our contribution. This is the like the at the end of what we make on of of the process of the information. This corresponds just for 1 month. Um, uh, I'm going to explain you rapidly one graph by one. This is the graph for active power. We can see the particular humps that represents for each day of the week, Monday, Tuesday, and so on. And this is for the weekend. What we can see here is that the meter number 3 is the more important one because it's the one that has more charge on. Um, Here we have the instantaneous currents of the 3 meters. We can see clearly here the variation of those currents. So we make another graph to present that presents the percentage variation of the currents in the 3 phases, and here now we can see clearly the variation. And this is important because if it presents a high variation of the currents, in the case of mechatronic engineering, the devices of control systems uh, needs to be supplied by very specific range of currents. So if the currents overpass that limit, our devices can be damaged, or the function of them at the end we won't we will don't get the same result. So it is important this graph. We have the maximum power demand supply. This is important for the bill because this is our charge in this rate in high voltage. Um, we can monitor the maximum power demand, and if we saw that if we see sorry if the power exceed the limit, maybe we can connect our proper generator and start to to work with this energy. So this is very important to be monitoring. And obviously, the cost of the energy, we can see that in the weekend also we have like a very amount of the costs we pay at the weekend. So we can analyze here the graph and say why we are paying a lot in the weekend. If we need to reduce the time of the buildings open, or maybe at the weekend the buildings need to be closed. So that's a manner to analyze. And below we have the consumption of the energy per day, in this case per day. We can also see that we have like a whole week. And as we mentioned it before, the general metric 3 has the more charged on, and it's important to analyze because here like example is the weekend, and here is the work week. And if it exceeds the average consumption of energy, there's something happen. And we can indicate in which meter is it, and go to that place and solve the problem. So at the end, conclusions, the needs of using this is because we need to make the frequency of use, the environmental factors that we said before. If the maximum power demand exceeds, we can connect with our proper generator to reduce that feed. Um, that involves the savings and obviously the security of the system. The management, we need to improve the operability to increase the performance. With that, we can make projections, we can planning the energy supply control as user, and obviously we can ensure the maintenance in memory of real measurement data. So that we're living in a very critical period of global warming, so this can be like a way to combat that fact, like connecting another our proper generator to use that generated energy, and obviously to use fewer energy, that can help a lot to combat this problem. So finally, I can say that this for me wasn't a very important project. I will be in Mexico uh, developing this kind of project. So I think this will be the future, and the future is now. So it is important to take note of these technologies.